video on how to divide indices. So first of all, we've got this question here. Now, I think often dividing indices is easier to think of them in terms of fractions. So just written this as a fraction instead of a divide sign. Okay, so we can think of indices as expanded form. So technically, y to the power of 6 is the same thing as going y times y times y times y times y times y. So there's 6 y's. And similarly, y to the power of 4 is the same thing as timesing y by itself 4 times. When we see it in an expanded form like this, we can just cancel things out one by one. So we cancel one y from here, and same thing for the bottom. And we see we cancel in pairs. When one thing goes from the top, we have to divide the bottom of the fraction by the same thing. And we see here, all we're left with is y times y on the top of the fraction, which we can just write as y to the power of 2, because there's 2 y's. Another way we can look at these, which is a little bit easier than doing expanded form each time, especially when these numbers get bigger. We don't want to be doing 14 y's or something like that when the numbers get really high for indices, is we can just look at them in terms of a fraction. Now, I look here, I see there's more y's on the top of the fraction than the bottom of the fraction. And there's 2 more y's on the top of the fraction than the bottom of the fraction. So I'm just left with 2 y's on the top of a fraction, which is the same thing as writing y to the power of 2. Now, it's a bit of an honorable mention for our indice law for dividing. So technically, when we divide, we're subtracting the powers, but often thinking about them in terms of a fraction is going to be easier, especially as the equations get more complicated. This technically is also an option. So over here would be 6 minus 4, which is just y to the power of 2. Okay, then we've got x to the power of 3 divided by x to the power of 5. So first of all, again, I'd write it as a fraction. And then here, if we want to, we can write an expanded form, and then we can cancel out. So 1x goes from the top, 1x goes from the bottom, and you see I've just color coordinated what we're canceling. And we're just left with 2 x's on the bottom of the fraction. For something like this, we just put a 1 on the top of the fraction, just to hold the value, and then x to the power of 2 on the bottom of the fraction. We put this 1 here just because we can't have the bottom of the fraction without the top of the fraction. It's just not something we can write out. Okay, and alternatively, we can not think about an expanded form as much and just look here and see we have more x's on the bottom of the fraction than the top of the fraction. And we have 2 more x's on the bottom of the fraction than the top of the fraction, which from there we can just say we end up with x to the power of 2 on the bottom of the fraction. Okay, here's a slightly more complicated question, but the same idea. So we have this number here, this term divided by this one. So again, I would write it as a fraction. Now, the first thing I would deal with is probably going to be exploring an expanded form. And again, expanded form you might not want to do for every question, but just demonstrating what we're doing. So you see here, there's only 1x here, so there's 1x here, there's 4 y's here, so 4 y's to go with that, and so on. And then I've just shown what we can cancel out. So we see we're going to be left with no x's or y's on the top of the fraction and 1x on the bottom of the fraction. And then from there, we can just simplify 6 over 8. And I've got a video on simplifying fractions, but essentially we're just going 6 divided by 2 and 8 divided by 2, which leaves us with 3 over 4. And then we have this x on the bottom of the fraction. Again, we don't need to write everything in expanded form. We can just look at our fraction here. So I would start by looking at this 6 over 8, simplify that to 3 over 4. And then for x's, I would look, there's more x's on the bottom of the fraction than the top of the fraction. And there's 1 more x on the bottom of the fraction than the top of the fraction. Because when we don't write the power is just 1. So we're going to end up with an x on the bottom of the fraction. And then we look here at the y's, there's the same amount on the top and the bottom of the fraction. So they just all cancel out. So you see here, we could go straight to 3 over 4x. Okay, another one of these questions. Again, I would write it as a fraction to start. So we see our fraction here. Now, we could write an expanded form if we liked, and then we would cancel out as so. Alternatively, we could go, that's just fully cancelled out. Alternatively, we could just look at our fraction like this. We could go, first of all, 14 over 21. I simplify that, and I simplify that by dividing both the top and the bottom of the fraction by 7. That gives us 2 over 3. And then I look at the x's. So there's more x's on the bottom of the fraction than the top of the fraction. And there's 2 more x's on the bottom of the fraction than the top of the fraction, because 4 minus 2 is just 2. Now look at the y's. There's more y's on the top of the fraction than the bottom of the fraction. And there's 1 more y on the top of the fraction than the bottom of the fraction, because 3 minus 2 is 1. So therefore, we're going to end up with our 2 over 3 from dividing 4 and 21 by 7. The x to the power of 2 on the bottom of the fraction, because there's 2 more x's on the bottom of the fraction than the top. And y to the power of 1, which we can just write as y, on the top of the fraction, because there's 1 more y on the top of the fraction than the bottom of the fraction. Okay, and that's all for dividing indices.